All right, so we paused on problem number 6, and now we're going to look at population correlation coefficient. Keep in mind, R stands for sample correlation coefficient. Now we will be looking into population correlation coefficient, which is your rho. So once you calculate your sample correlation, which we did in the problem, what you will do is you will want to check whether there is enough evidence to decide that the population correlation coefficient is significant. So let's go ahead and see how that is done. We will have a table that will be given to you where you have to look into the correlation coefficients of the population, and then you will compare your sample correlation with your population. So how is that done? So let me go ahead and change my pen tool here. So you will take the absolute value of R, and if R is greater than your critical value, which you will be getting from the table, keep in mind you cannot come up with these numbers. They have to be given to you. So you compare your R to the critical value, and if R is greater than the critical value, then there is enough evidence to decide that the correlation coefficient is significant. Okay? So if R is greater, the absolute value of R is greater than the critical value, then there is a significant evidence that the correlation coefficient is quite significant. Okay? All right. So you will be using your table. You have your table right here, and we will take a look at how it's done. Keep in mind n is your sample size. You have to know your sample size. And you also have to know your type 1 error, which is your level of significance alpha. You will have different alphas. One is 5% or the other one is 1%. So depending on the problem. All right. And then once you compare, you will see what is happening. So let's take a look at what we have here. Determine whether rho is significant for the 5 pairs. So my n value is 5, right? And my alpha value is 0.1. So my n value is 5 and alpha is 0.1. So my critical value is 0.959. So what I do is I compare my R to the critical value. If R is greater, then the correlation is significant. If not, there is not enough evidence to conclude that the correlation is significant. So let's go ahead and see how this is done. First, you're going to see how many pairs of data that you have, which is your n value. You will specify your level of significance. Alpha is 5% or 1%. You will find your critical value from the table that is always given to you. And then based on your R and your critical value, you will determine if the correlation coefficient is significant or no. So if it's not significant, the verbiage that you use is there is not enough evidence to support your correlation coefficient. And based on that, you will interpret your decision. All right? All right, so now let's go back to our problem where we stopped here. We have, we finished part, I don't even know what part, I think part C, and we're looking at part D. Use the table of critical values of the Pearson correlation coefficient to make the conclusion about the correlation coefficient. Keep in mind that you have to find your critical values from the table, and your alpha value is given to you. And I also need my n. My n is my sample size. So I will click on my data set. And when you open this in StatCrunch, I think we did open this in StatCrunch. Let me take a look. Yeah, when you open it in StatCrunch, the sample size will be given to you. Do you see it says sample size? Let me expand this right here. Da, 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 da. All right, let me expand this one so y'all can see. Da, 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 da. So the sample size is clearly given to you. So you know your sample size is n. So my n is 11 here. That's my n value, right? So now let me go back. My n value is 11, and I'm going to go ahead and click on my Pearson correlation coefficient. Scroll this up. I'm going to go all the way down. My n value is 11, and my alpha is 0.1. So that's the second. Let me go back from the beginning. So alpha is 0.1, which is the second column, and the n is the first column. So let me go ahead and see. So my n is 11 and alpha is 0.1. So my critical value is 0.735. So my critical value is 0.735. Again, you will have to have your n value and your alpha. If your alpha is zero point 0.5, then you will be looking at the first column. Let me minimize this one so y'all can see. Yep. N value is 11. Alpha is 0.1. So this is 0.735. Okay. Always you need to know your N value and your alpha value. 0.735. Keep that in mind. And the critical value is 0.735. Okay. So what happens now? Once my critical value, what is my correlation coefficient? So let me go back here and get my correlation coefficient. My correlation coefficient is 0.977. So my correlation coefficient is 0.977. This is my R value, the absolute value. And my critical value here is 0.735. So I clearly see that my R is greater than my critical value. When R is greater than critical value, what do you conclude? So if your R is greater than your critical value, then you say that there is enough evidence to decide the correlation coefficient rho is significant. So let me minimize this one here. That's not going to work. So my R value was 0.977 and the R value is 0.735. So my R is greater than critical value. So there is enough evidence to conclude that there is a significant linear correlation. And you check your answer. All right, so let's go ahead and take a look at the next one. Problem 7, y'all can do let me do problem number 8. And again, you start with the table, shows that the earnings per share and the dividends per share of 6 companies in a recent year. So you automatically know your n value is 6. So you'll click on your table here to look at your data set. Open the data in StatCrunch. I will expand this for you and of course minimize it again. Stats, remember where you go, regression and simple linear. So your x variable will be your x and your y variable will be your y. And you will compute. A couple of things you have to take into consideration is your sample size, right? Your sample size, which is your 6, and also your correlation coefficient, which is 0.0835. So I'm going to go ahead and plug that in. Going back to, let's see, I'm going to take this off. Going back to the problem, I need my graph first. So I'm going to go ahead and look. Where do you find your graph? Click on the arrow. The graph, you will see your graph right here. By looking at the graph and by looking at the correlation coefficient, there is not that significance of correlation here. But let's go ahead and take a look what options we have. One is going all the way up. Do you see option A? Let me get my arrow right here. This is going all the way up, and I have a correlation that is almost no correlation, no correlation, correlation going down. So definitely my options are not option A and D. Now my next step is to find which one is my option here. So I will go back to my graph and you will see that what I want you all to focus is sometimes the graphs could be slightly confusing. So look at the points here. I have 2 points right here, and above I have 2 points here. Do you see that? And then a point here and a point here. And my fitted line is something like this. So let's go ahead and see which one would be in my options. You can expand every graph. So 2 lines. And also the easiest way to do is by looking at your data sets. Here, when I click on my data set, you will pretty much see the values here. So you open this one, you have 2 values here and here. So look at the data sets. I'm going back to my data set here. So I have 0.99 and 0.7. Let me go ahead and sort it. 0.99 is 0.97. So I'm going to go back here, and they all look pretty much the same for me. So looking at my data values, 0.99 is right here. So, and if you look at option C, I don't have any 0.99. I only have 1. So I'm going to go ahead and click on my B and check my answer. Good job. And now they're asking me for correlation coefficient, and I will look here, go back. My correlation coefficient is, where is it? 0.8351. Let me go ahead and copy it so I don't want to go back and forth. I did not check how many decimal places, but I'm going to check in a minute. 3 decimal places. Go ahead, plug that in. Boom. 1, 2, 3. So 4. Fantastic. And now it's 0.0. As soon as you see this 0.0, there is absolutely no correlation here. There is no correlation. 0.08 is very, very small. So there's no correlation. As soon as you see 0.0, by default, you will know that there is no correlation. So now your part is to interpret your correlation. As company earnings per share increase, the dividends tend to increase. That's not what we saw. Based on the correlation, that does not appear to be a linear relationship between the company's per share and the dividend. So that's what I'm going to check, because there is no linear correlation. And now for the next step is to go ahead and calculate my critical value. To calculate your critical value, my n here is 6, right? I'm going to go ahead and show it to you really quick. You see the sample size is 6. Very good. And my alpha is 0.1. Do you see the alpha value here? Alpha is 0.1. So I will click on my critical values, and I'm going to zoom this one here. My n value is 6 and my alpha value is 0.1. So my critical value is 0.917. I'm going to go ahead and plug that in. 0.917, hoping that is correct. And now what is my next step? My next step is to compare my critical value. So I'm comparing my critical value 0.917. That is my critical value. I'm comparing it to my correlation coefficient of the sample, which is R. I got it as 0.083. That's a 3, trust me, and a 4. So I see that absolute value, of course, this is definitely less than. So when it's less than, what do I say? When the critical values are less than, the verbiage that you use will be, there is not significant evidence at 1% to conclude that there is a significant linear correlation. So I'm going to pause right here and pull up the chart for you. So you see that if the R value is greater, then you will say there is significant. Otherwise, there is not enough evidence to support that the correlation is significant. So let's go ahead and do that. So there is, check your answer, and good job. All right, so the next couple of questions pretty much y'all can go ahead and answer, but please, please, please make sure you have your notes in front of you and also pen and paper. Problem number 9 is they're simply asking you, let's see, the ages of 10 men, systolic blood pressure are shown in the attached data with the sample correlation. Okay, they're asking you to remove the data entry of the man who is 50 years and has systolic blood pressure and calculate your correlation coefficient. So if I click on this data set here, you will open your data set in StatCrunch. And they're saying, hey guys, we have given you a set of data sets. They said, go ahead and remove the guy whose age is 50. And now calculate your correlation coefficient. And they say, now calculate your correlation coefficient. So that's exactly what you will do. You will remove the guy whose age is 50, and you will go back and calculate your correlation coefficient and then tell them what the new correlation coefficient is. Okay? All right. Yep, y'all can do this one too. Please make sure you read what they're asking you. They're asking you to interchange your row 1 and row 2, and they want you to see what the new correlation coefficient is. Is there a difference between a correlation coefficient or no? So hope this helps. Make sure you finish your homeworks. If you have any questions, don't hesitate to email me, text me, and take care.